Okay, so question number 2. For the molecule CH2Cl2, so this is dichloromethane, draw the Lewis structure, determine the geometry, and determine whether the compound is polar or nonpolar. So when drawing out the Lewis structure, we first need to calculate the total number of valence electrons. So carbon has 4 valence electrons, hydrogen has 1, and since we have 2 hydrogen atoms, we multiply this by 2, and chlorine has 7. And again, we would multiply this by 2 to give us a total of 20 valence electrons. So now when we draw out the Lewis structure, we can start off by drawing out a skeletal structure with carbon as our central atom. And then I can show the 2 bonds to hydrogen and 2 bonds to chlorine. And now I can fill out the octet in chlorine by drawing in all of the lone pairs. Okay, so if I count out all the electrons I have so far, where each bond contains 2 bonded atoms, you can see that I already have my 20 electrons drawn in the structure to have the correct Lewis structure. So now we need to determine the geometry of this structure, and to do that we can analyze the central carbon atom. So if we look at the carbon, it has 0 lone pairs, and it has 4 bonded atoms. So by using a Vesper theory table, like so, when we have 4 bonded atoms and 0 lone pairs, we have a tetrahedral molecular shape and electron geometry. Okay, so for the last part, we need to determine whether or not this compound is polar or nonpolar. So to do this, we need to determine whether or not we have any polar bonds in this molecule. So to determine the polarity of a bond, we need to look at the difference in electronegativity values of the atoms involved in the bonds. So for example, to determine the difference in electronegativity between carbon and hydrogen, we need to look up the electronegativity values for both carbon and hydrogen, and then find the difference between the two. Okay, so here's one chart, a periodic table that lists all of their electronegativity values. So it's kind of rounded off, but for carbon, its electronegativity value is 2.5, and hydrogen's is 2.1. So the difference between the two is 0.4. So this makes the carbon-hydrogen bond nonpolar. And we know that because their difference in electronegativity is less than or equal to, well, equal to in our case, 0.4. Okay, so now let's calculate the electronegativity difference between carbon and chlorine. So chlorine's electronegativity value is 3, and carbon's was 2.5. So the difference between these two is 0.5. The carbon-chlorine bond is polar. So this is because its electronegativity difference is greater than 0.4, but less than 1.69. So now that we know that the carbon-chlorine bond is polar, we can show dipole moments towards our chlorines in the molecule, like so. So we have an overall non-zero dipole moment since the hydrogens aren't electronegative enough to cancel out the dipole moments. So therefore CH2Cl2 is a polar molecule since we have an overall non-zero dipole moment. Okay, so let's see what the junior tutor said. Get the total number of valence electrons for the molecule, so they also got 20. Using this information, construct a Lewis structure in such a way that the octet of each atom is complete. Okay, so they showed a 3D structure. And looking at its structure, CH2Cl2 has a carbon as the central atom, 2 hydrogens, 2 chlorines, so it has a tetrahedral geometry. And because the 2 chlorine bonds create a dipole moment towards chlorine, since chlorine is more electronegative, this creates a net dipole moment. Thus, we have a polar molecule. Okay, so this solution is correct. Okay, so I'm just waiting for this. Okay.